Okay, Calculus, Unit 7, Day 61, Part 2. We want to sketch a slope field for a given differential equation. So the slope field should look like a collection of f of x's, not a collection of the f prime of x's. So it's going to be parts of the function, even though we're given the derivative. So it's not going to be what the derivative is. Okay? So given the differential equation below, compute the slope for each point indicated on the grid to the right, then make a small mark that approximates the slope through the point. So it's only going to be a little segment at each point. And you look here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So I have 30 points. I'd have to actually fill out all 30 of these. So I think this is not that bad. So when they tell me the dy dx, the differential equation, which represents the slope, hey, this is equal to x minus 1. I pick any of these points on here, and I'm going to pick these four. Notice they all have y as a 3, and notice the slope is x minus 1. So that doesn't even matter. But, I mean, the y doesn't even matter. It doesn't even come into play here. So x is negative 2. Um, so I'm going to do negative 2 minus 1, which is negative 3. So I'm going to find point negative 2, 3, and I'm going to do a slope of negative 3. So I'm going to say that's my slope right there. That's steep enough where first of all, it's going negative, and it looks like it's negative 3. I'm not going to be exact every time. Negative 1, 3 is going to be right here. So that's going to be negative 1 minus 1. That's going to be negative 2. It's still going to be negative, but it's going to be less steep. You're getting closer and closer to being horizontal. 0, 0, 3, so that's going to just be 0 minus 1, which is negative 1. Again, still going down to the right, less steep. And now 1, 3, would put x is 1, 1 minus 1 is 0. Hey, that's horizontal. So now I want to do that for every single point. And let's take a look at what that is. And hopefully what I see is, hey, if I'm at 1, 2, it's still going to be 1 minus 1. That's 0. So this pattern is what it's going to look like here. Okay, and when x is 0, they're all going to be the same. They're all going to be 1. So I should have a bunch of these parallel segments here. Oh, that was a little too steep. Same thing here, a little more steep. And this is negative 3. Okay, and then over here, this is x is 2, 2 minus 1 is 1. And all of these are going to end up being the same. Okay, if you think about that, this is and we're going to do this later on, but just to start thinking, this is degree 1, the slope is all linear, so the derivative is linear, which means the antiderivative will be quadratic. So those are all going to be parabolas, and I can start to see there's a parabola, so it starts to show us what the actual general solutions are going to look like given what the differential equation was. Okay, let's move on to the next one. Okay, so here's our differential equation. We know this is the slope. And again, I have 30 points here. Let's just pick a couple. Now there's an x and a y, so this is going to be negative 2 minus 3, that's negative 5. So I'm going to go through and negative 2, 3, that's going to be negative 5. It's pretty steep. And negative 2, 2, negative 2 minus 2 is negative 4. So negative 2, 2, that's a little less steep. That's sometimes hard to generalize. Negative 2 minus 1 is negative 3. Again, a little less steep. Negative 2 minus negative 1 is plus 1. So that's going to be equal to negative 1. That's down here. Much less steep. And now we just do that for every single problem. So here's the finished product, and we can kind of see that these patterns go, these are all the same, these are all the same, these are all the same thing. I might have made these a little too steep, but that's okay. So whenever we're sketching a slope field and we're given a differential equation, not that bad. Okay, let's look at the next one.